Okay, hello everyone. So today I'm going to provide you a Unit 1 review for AP CSP Unit 1. In this review, we'll be covering contents including bytes, binary numbers, number limits, storing text in binary, converting analog data into binary, and the needs for compression, and at last, copyrights, DRM, and the DMCA. Okay, so let's get started. So before we get started into our review, we can have a small introduction on how computer networks work. So to get you started for the first unit, I'm going to explain to you two types of networks. There are of course more, but we're going to cover only them two today. So one is the wide area network, which is also called the WAN. It is a typical it is a typical computer network that spans large geographical areas and also helps to connect local area networks. But in general, it is a telecommunication network that extends over a large geographical area, often like spanning cities, regions, countries, or continents. Um, it is used for businesses, government, and other places. Well, this is just additional information, and technology. Some technology uses of WAN is like VPN, so it creates a secure tunnel over public networks like the internet, allowing safe access to remote networks. And then we have the local network, LAN. So it is a network that connects computer devices within a limited geographical area, such as home office or like smaller group buildings. So it can be going through like such too long area comp- compared to the WAN. But it also has advantages. So for example, it has a really high data transfer speed compared to WAN and other networks. It is transmitted rates like often ranging from 100 Mbps to 10 Gbps or higher within modern urban net standards. LAN is mostly used for file sharing, resource sharing, and it is also used in like Wi-Fi's and token rings. Token rings are really old, uh, pretty less common thing today, to be honest. And just to define computer network is like a group of any interconnected computer devices that are able to send and receive data between each other or in a bigger group of devices. And now we can finally begin into our unit topic. So what makes up our information? So all the data and all those graphical pictures and information you transfer between phones, computers, and iPads. So they're actually all made out of ones and zeros, and ones and zeros are called the bit. And then we have the bytes. I don't know why it's why though, but bytes are eight of the bits. So it represents 8 bits. So for example, 1 0 1 1 1 0 0 1. It is an example of bytes because it contains eight individual bits, which are ones or zeros. Okay, now we're on our next step, which is binary number system. So a binary number system is when each digit in the binary numbers represents a power of 2, like starting from the rightmost digit. So let me show an example. So look, we have the number 1010. This should equal to 10. Let me tell you why. So we can see that this is the first place, which is 1, and here, and then we use 0 times 1, and then plus, because as you guys can see, this is the first place, and we have 0 here, so it's 0 times 1. And then here is the second place, so we can have, since it's here is 1 and not 0, so we have 1 times 2, and then we have the fourth place. This would be, well, you guys already see the pattern, so this would be 0 times 4. Okay, I forgot a plus sign here, So there's a plus. And then here is the eighth place. Yeah, I guess you guys already see the pattern. So every place is like the power of 2. So for example, 2, 4, 8, this is the third power, second power, and the first power. And then, so going back to the lesson. So as you can see, the fourth place is 1. So we have 1 times 8, and then, oh, the plus sign. So after we add all of these results up, we get 10. And this is the number I was talking about before. So in the decimal system, each place represents a power of 10, because like the answer is 10, as you guys can see. And while in the binary system, each place represents the power of 2. Well, that's what I explained to you. Okay, now we can go on to number limits, overflow, and round-offs. So let's start with number limits. So, so computers store numbers using a fixed number of bits, as we all know. So, and there will be a maximum and a minimum value that can be represented. Let me show you an example. Okay, guys, so here you can see the code, and the first set of code is calculating the maximum possible values for a 32-bit single integer. And the second line of code would be printing it out, and then the min value, which would be the minimum possible value for a 32-bit integer. And then here we can run the code and see the result. So here, as you guys can see, the answer for max and min. So these two represent the maximum possible value and the minimum possible value. And if a number exceeds these limits, overflow will occur. This will lead to a unpredictable behavior in some systems. Yeah. And now, guys, let's go back to overflow, because we just talked about it. So overflow is when calculating a result in a number that is outside the range that can be represented by the system. So let me show an example. Here we are trying to calculate the number when it exceeds the limit of 32-bit integer, and it wraps around the constant error. But you guys also can see this is on Python, and it can handle this easily. So if you run the code, it will give us the answer. But in languages like Java and other languages, it will cause a different type of answer, which we're not going to cover today because it's only a Python review. And then now we can come back to round off errors. So round off errors occur when floating point number cannot exactly represent certain values, and this will lead to smaller inaccuracies in calculations, especially with repeating decimals or very large small numbers. Let me show you an example. So as you guys can see here, we have the expression 0.1 plus 0.2, and we're trying to store it into the variable a. Due to the limitations of how floating points numbers are represented in binary, the result of this addition will not exactly be 0.3. Instead, it will be like 0.3000000. And so let me show you guys. See, and then we print it out. And the third step, we check for equality. Because like the a is actually 0.3000000 a bunch of zeros and ends with a 4, the comparison a equals to 0.3 evaluates to false, and this will lead to a runoff error. So why does this happen? So in binary, so one of the causes would be the binary representation. The numbers 0.1 and 0.2 cannot be represented precisely in binary form, and this leads to smaller errors in calculations. And another example of this would be round of error. This slightly uh, deviates the expected result and will do and will make the floating point arithmetically work in computers. Yeah. Okay, guys. Now we can move into our next topic. So it is storing text in binary. So for every letter, digit, or symbol in text, it is represented by a number in a character encoding standard. So today I'm going to introduce you about the ASCII, and here's the website link. It is like a website where it shows the code for every letter and number. So for example, now we go into the website, and here we can see letters and numbers with their code and number. So for example, if I want to print hi, so we find H and then I, so it's 72. First 72 is H, and then 73 is 70. Let's find I. It is 73. Yeah. And then we come here, and here's the code. Uh, so if here it has the smaller letter I, so it's 105, and the front value ASCIIH equals 72, so it's taking number 72 out of that library basically, and then we print the number 72 character and the number 105 character, and it will result into a high. You see, so we basically coded all of the letters and numbers into one system, and then if we want to use every, like for example a number or a letter, we just type the number from that system, and then we can get the number straight away. Okay, now we can move on to our next lesson, and this will be converting analog data to binary. So this, I'll just give you a simple review on what does each definition is. So the four definitions we need to know in this topic is sampling, quantization, analog, and digital data. So sampling, so this is like a signal wave where you have to measure it, and analog is the data that is continuous and represents real-world signals such as sound waves or light intensity. Quantization is continuous values of analog signals are that are rounded to the nearest value within the fixed range. And digital data is discrete and uses a finite set of values to represent bytes. So it's basically zeros and ones. And in just a brief summary, so simple definition for this topic would be this analog to binary conversion. This involves measuring an analog signal and representing those measurements as binary numbers, so it's zeros and ones. And this process is commonly done using an analog to digital converter, which is ADC. Um, this sample would quantize it and outputs the corresponding binary Y values. So, for instance, if an analog signal represents a temperature that varies smoothly, the ADC sample, the temperature at specific moment, transfers those measurements into binary numbers like 101010 and sends them to the computer for processing. That's what this topic is about. And here we have our compression topic. So I'll be explaining compression algorithm and lossy compression. So in lossless compression, the algorithm replaces the repeating sequence of data with a single value and the count. So for example, a sequence like AAABBB would be compressed as 4A3B. So this minimizes the amount of data and makes more efficient communication between devices. Okay, so now I'm going to introduce the RLE decompression. So this RLE decompression is a method to reconstruct the original data from its compressional format, where sequences of the same character are stored as a single character followed by a count. And how does it work? So in RLE compression, characters are represented as single characters followed by the number of times it appears consecutively. So for example, well, as I showed before in this is kind of the same, but but the RLA decompression algorithm, the goal of this is to take the compressed string and expand it back to its original form. So as you can see this, so for A3B would be expanded back to AAAABBB. And now let me show an example of it. So according here you can see the code and and the first, so the compressed, so here it is an empty string that will hold the final output, and count is an empty string that is used to accumulate the digits representing the count of the characters. And then we go down to code, so here's a for loop. The for loop goes through each character in the compressed string. So if the character is a digit, so here it appends the digit to the count string to handle the multi-digit count. So example 12a, if the character is still not a digit, it would check if the character is just a count stored. If the count is not empty, it converts a count to an integer and appends the corresponding character repeated that many times to decompress, and then it resets the count for the next character. And if the count is empty for a single character, it simply appends the character. So here we run the code. As you can see that here for A3B2C, after we decompress it, it will get the result of 4 A's, 3 B's, and 2 C's. Correct? Um, so they are connected actually. Now let's get back to our next topic. So here's the copyright, the RMM, and the MCA. So these three are the legal aspects of digital data. So they're here to protect creators, making sure that no one can use their work without permission. Here we can start from copyrights first. So we can break copyrights into four parts: exclusive rights, duration, public domain, and fair use. So exclusive rights, this is the copyright law granted to creators. So over their original work, these rights are a set of legal protections that give the creators control over how their work is used. So they have the total rights to do whatever they want with their own work. So like reproduction, distribution, derivative work. So it could be the rights to sell or otherwise distribute copies of work, and the rights to create books about the work or like put it in a movie. And then second one we can go to digital trust digital transformation. So for sound recordings, the right to perform the work through digital audio transmissions, streaming music. Well, this is not related to code, but it's still part of the knowledge we need to know about. So second part, duration. So this copyright does not last indefinitely. The duration of the copyright protects depends on the type of work and when it was created. So this one limits the time of your copyright to last. And the third one, public domain. So this is so when public domain are not protected by copyright. So this means anyone can use, copy, distribute, or adapt the work without permission from the original creator. So for example, when you so for a copyright that is lasting 70 years, after the 70 years, the work would enter into the public domain. So it means that everybody can use it however they want. And the last one, fair use. So this is a legal doctrine that allows limited use of copyrighted material without obtaining permission from the copyright holder. So, in other words, fair use is a legal rule that lets you use small parts of someone else's copyrighted work without needing the permission. So, as long as you're like, doing the uh, work in some specific ways. So, like commenting or criticizing in a book review or a news article, or teaching or learning, like classroom or research. And now let's move into our second part. So this part is about DRM and the DMCA. Okay, now I'm going to start with DRM. So DRM is digital rights management. DRM refers to technology used to control how digital content, such as music, movies, ebooks, or softwares, or how they can be accessed or shared. So this copyright helps you helps you with preventing distribution and privacy by imposing limits on what users can do with the content, like restricting copying or limiting the number of devices it can be used on. And second one is the MCA, which stands for Digital Millennium Copyright Act. This is a US law that strengthens copyright protection in the digital age. It prohibits bypassing the DRM and allows copyright holders to issue or take down the website hosting infringement content. It also gives protection to online platforms, helping them for being more reliable for users to upload content as long as they comply with the takedown requests. And that's all for today. Thank you for watching.